Okay, so here is a point cloud of a balcony that we're making these curved railings replacements for. We were on the inside, so obviously we didn't see the outside of anything. But all I really need is a section of each brick face that we are actually attaching to make a plane off of that I can work from. So what I have is this, which when viewed from the top gives you a very crisp and clear corners on all of your brick columns and shows the handrails sections coming out that I deleted most of because you only need a tiny little section there. So then what we're talking about as far as how to work off this is two ways. And generally speaking, if you're going to be working in SketchUp, you're going to zoom in and see this right here, this width of this point cloud. So the difference we need to take into consideration is precision versus accuracy. So the precision of all of these points is going to be individually slightly off, plus or minus as much as 2 millimeters. So if you were to measure this, you would get probably roughly 2 to 3 millimeters in thickness of this wall. But the accuracy of them all put together gives us an extremely accurate plane that we're going to attach to. So what I'm going to do is, including this little bit over here and all of this right here, I'm going to make a plane, which is the same thing you would do in SketchUp. Not mesh, not fitting, model, cloud-based modeler. That will basically be in the center of all of those. And the center of all of those is going to give us a very accurate plane. Let's see. So even though you can even see where the grout lines are, that's the depth of those grout lines. So these are all already super, super precise. But what we're talking about, and that's some noise, that's a little bit of a different thing. The noise of these random dots out off in the distance, that has to do with when the laser hits an edge of something and comes back in two places. Basically, it'll come back from hitting this edge and it'll come back from hitting something out further beyond. And so if half of the laser hits back over here and half the laser hits over here, you'll end up with a point in the middle. But that's negligible. Those are such a small thing. So anyway, you basically, what we're going to work with is this right here. So obviously, okay, where do I work with, where does the actual plane exist in this? And the answer is not limit box, not segmentation. Here we go. So plane fit right there. And if you look down on it, you can see that it's basically vertical. The distance that it runs laterally is extremely small when looking straight down. But you do that, so that's super simple in SketchUp. You'll basically just draw a line from here to here. And I brought that over here because you can see that it kind of comes off slightly at the back. And I'm not 100% sure what that is. That might be a brick that's slightly recessed. But I'll go through and be cleaning these up individually one by one. Okay, so now we have our plane. Close that and then go to plane bounding, and we'll just go here, make it the eggs outside, turn off the limit box, boom. And so now that plane, unfortunately it eats up the points the way I did this, so this sample is now missing those points, so I shouldn't have done it that way. But you usually work off of a different one. But yeah, so I'll put those in all 4 locations for each rail, and then I'll have a super, super, super accurate super accurate plane of the face of those bricks. And if you really wanted to get accurate, you could delete the grout line. you know, and you can do that in recap just fine. But it's the same concept in SketchUp. You pretty much want it to be in the middle of that selected point cloud, more or less, and that's what you end up with.